All right, glad you guys all made it in today. Certain spots and certain roads were a little slick this morning.
I ate it on my driveway.
Ate it? For a lot of people, ate it. I ate it the other night on my driveway, but I was trying to not go into a puddle. Yeah, it was kind of nasty, but it's think of it this way. I'd rather have it rain. Yeah, exactly. We don't need no more snow. Yeah. Oh no. Definitely no on that one. Okay.
It's not going that time to come back from spring break.
I don't know. We'll see. So what I was going to say was, before we even get into this, is that if you have a R value, so we're sitting here and we're talking about the G sub n equals G sub 1 times R to the n minus 1 power, right? When we're dealing with that, when this R value, you should just get into the habit of putting that R value inside a set of parentheses, okay? Especially if R is negative, okay? So on the homework and on the formative, I marked them wrong if you didn't put R, a negative R, in a set of parentheses. And the reason is, mathematically speaking, if I type this into the into a calculator, my answer is going to be -9. Okay? Because the squared is only controlling the 3, not the negative sign. So this is -1 times 9, which is -9. This, if I type it into the calculator, gets me +9. Because now I'm taking -3 times -3. Okay? And those two are different. I can't read your intentions on your paper. You know what I mean? You might want it to say, yeah, -3 to the n minus 1 power, but without putting that -3 in a set of parentheses, it doesn't mean the exact same thing. It means something totally different. Okay? So, going forward, tomorrow on your quiz, next week, all that stuff. When we get to the test, make sure we put our R's, and even just get in the habit of, even if you have a positive R value, put it in a set of parentheses. Okay? Not going to hurt anything. Okay? All right? So I wanted to get that out of the way first. Okay? Today, I got 3 examples to talk about. Okay? And then work time after that. And the 3 examples that we have to talk about aren't very long either. Okay? So well, you should have at least a mod, maybe more, to work on the worksheet, fixing anything, all that fun stuff. Okay? All right. So, starting salary of $29,000. You guys are all going to get jobs sometime in the near future. Okay? So let's say your potential employer says, hey, we're going to start you with a starting salary of $29,000 per year. Okay? And then we're going to guarantee a 4.5% raise every year as long as you work with us. Okay? In the last class, Colin was telling us that Quick Trip, if you are a full-time employee at Quick Trip, theirs is 3%, but they have this basically this scenario where they start you at this certain amount of dollars, and then they guarantee you a 3% raise for the rest of your career at Quick Trip. Okay? So it's out there. There's things like this out there. Maybe not this big, because that's 4.5% raise is a pretty big raise every year. Okay? All right? So, this one is geometric. And the reason it's geometric is because it's a percentage increase per year. If it said something like, we're going to guarantee you that we're going to add $1,500 to your salary every year, that's an arithmetic increase. because it's always 1,500. Percentage, it's going to take your 29,000, increase it, then it's going to take what that increase is and increase that by 4.5%, and then so on and so forth. Okay? So it's a pretty good game. So let's figure out our rule. So geometric, so it's a G sub n, is going to equal G sub 1 times R to the n minus 1 power. Now, I know what my first term is, right? What's my starting salary? 29,000. It's that R value that I'm worried about, or that I'm wondering about. What's the R value going to be? What's my R value? Okay, so can't really use 4.5%, but I could use it as a decimal, right? Okay, so what's 4.5% in a decimal? Anybody? 4.5% in a decimal? What? No, that's 45. 0.045, right? Okay. So we're going to multiply 29,000 by whatever my raise is, and that's going to be more, right? Okay. So if I type in a calculator, 29,000 times 0.045, what do I get? 9,000 times 0.045. What do we get? 1,305. So in my second year, I'm going to make $1,305. So is there any way that I can combine all that into one R value? Because remember, we don't add in geometrics. We add in arithmetics. Okay, let's try that. So, because you're saying, so we should be making $30,305 in the second year, correct? Okay, so if I go 29,000 times 1.045, do I get 30,305? Yeah, okay. So my R value here is 1.045. Let's use the Quick Trip model, the 3% increase. What would my R value be at Quick Trip if I'm increasing by 3% every year? 1.03. Good job, Kurt. Okay? Let's say my company started me out really high. Let's say they did a kind of a reverse salary scale. They started you out at 500,000. But then they decreased your salary every year by 5%. Well, because you make so much money off the start. You know what I mean?
First year.
I'd probably stay for 3 or 4 years because otherwise you're making instead of making 29,000 your first year, you're making 500,000 your first year. Okay. So what would the R value be if they're decreasing by 5% every year? No. How did we come up with the 1.045? 0.95. Yeah. Okay, so we came up with this one by going 1 plus our rate, right? Well, our rate in the decrease example is subtracting, or negative 5%. So that would be negative 0.05. So 1 plus negative 0.05 is 0.95. Okay? So, thinking back to mathematical logic, if we're growing, this value here, this R value, has to be bigger than 1. If we're decreasing, it's got to be less than 1. Okay? Right? So, if I want to find the salary of somebody in their 20th year, that would be G sub 20 is going to be 29,000 times 1.045 to the 20 minus 1 power, which is how much? Calculations abounding. Anybody got it yet? Literally just have to type that in.
Looks like fun in here.
You're going to need a calculator today, just so you know, for your homework. Okay?
66,927.
66, but now we're talking money here, right? So how many decimal places should I go out to? 2. So 66,927.95, because it's 949. Okay. The question of rounding is logic. Okay. If you're in a money problem, 2 decimal points is what we would round to. If you're in a human beings problem, whole number rounding to. Okay? If you're in a grams of a substance problem or pounds of in a load, okay, then those directions would be, or those rounding directions would be in the problem somewhere. Okay? Or days or minutes or something like that. That would be, those directions would be in the problem somewhere. Okay? All right? Next question. What is the total salary for the person's career after 10 years? So they work with that company for 10 years. Total salary, what's that? Mathematically, what's the word for it? It does start with a sum. Okay? It's a sum problem. So I want the sum of the first however many years. In this case, 10 years. So if I'm going to use the sum problem, then that's going to be, I'm going to use probably the easiest one to use. Actually, let me switch this back to n. S sub n is going to be G sub 1 times r to the n power, then minus 1 all over r minus 1. Because in this particular case, it's the least amount of figuring that I have to do. I know my first term, I know my r value, and I know my n value. Whereas the other one, I'd have to calculate how much money we made in the 10th year, then multiply that by r, then subtract off G sub 1, and more calculations. Okay? So this is going to be 29,000 times 1.045 to the 10th power, then minus 1, all over 1.045 minus 1. Again, I would start on the inside. I would go 1.045 raised to the 10th power equals minus 1 equals times 29,000 equals divided by, and in my brain I can do that subtraction, that's 0.045. And in the first 10 years, this person has made $356,358.07. What do you got, Russ?
I just said and 7 cents.
And 7 cents, yep. And that's important because it's a money problem. So, yep. So we would round to 2 there. Okay. Oops. Did that one already? All right. So a ball is dropped from 6 feet. Now, so if we drop a ball from 6 feet, what's going to happen to the ball? It's going to go down. It's going to hit the ground and come back up. Is it going to come back up to 6 feet? No. Okay? Because gravity takes a hold of it. There's no extra force. When you're dribbling it, then it comes back up because you're putting force into pushing it down. But if I just straight up drop a ball, it's going to go down 6 feet, come back up a certain amount. Then what's going to happen? Now it's going to go back down, hit the ground, come back up, but it's going to come back up to a lower height again, right? And it's going to continue on in that pattern, always getting lower and lower and lower. Okay? All right? So if I am asking in this particular problem for the total distance that that ball travels, what are the 2 directions that that ball travels? It travels down, right? And then it travels back up. Well, let's chart that a little bit. Okay? So let's start with the downs. Okay? Because we're going to start and we're going to drop the ball. So the first distance down that it travels is 6 feet. Then it travels up. How far up does this particular ball travel? How much? 4.5 feet? Yep. How'd you get that?
75%
Of the previous height, right? Okay. So 6 times 75% or 0.75 is 4.5. So it travels up 4.5. Then what? It goes down 4.5 feet. And then what? 3/4 of 4.5. Anybody? 3/4 of 4.5? So then it comes back up 3.375 feet. Then it's going to go down 3.375 feet. And it's going to keep repeating that process, right? So how many sums do we have to find? How many sums do we have to find? Or one method. We have to find the sum of the downs and the sum of the ups and add them together. Right? Okay, that's one method. There's multiple different methods for this one. In both cases, what's the R value? What do you got? 0.75 is the R value. Right? Okay. Now, total number of terms. So we went down, and then we went up, then we went down, and then we went up, then we went down, then we went up, and so on and so forth. So this is bounce number 1 right there, bounce number 2 right there, bounce number 3 right there. Okay? Actually, let me erase. Oops. Erase this one. Okay? Agree with that? Just that quick, brief scenario, right? So downs, to get to 7 bounces, it would be how many downs? It'd be 7, right? Ups, to get to that 7th bounce, how many? 6, because it's 1 less, right? To get to that 7th bounce. Okay? So, we got it all situated now. So the sum here is going to be, the sum of the first 7 downs is going to be 6 is my first term, 0.75 is my R value, 7 is my N, minus 1, and then 0.75 is my R, minus 1. Six, open parentheses, 75, raised to the 7th, then minus 1, all of that being divided by 5 minus 1. I get here, this is 20.7964 feet. So the ball has traveled. If I drop a ball from 6 feet and it rebounds to 3/4 of the height every time, the ball just traveling down is going to travel 20.7964 feet. Okay? Okay? Ups. So now this is going to be the sum of the first 6 terms, the first 6 ups. 4.5, 0.75 to the 6th power. I get here, oops, that's a bad 5. Now I just got to redo the whole thing. I get here that this one is 14.7964. And I didn't even use a calculator. What's the difference between the two sequences? The original 6 feet. That's my extra term on the down. Okay? So now how am I going to find the total distance? Add those two together. $35.5928 really feet. We'll call it 35.6. Okay? Downs plus ups. One last one. Certain strain of bacteria decays over time. If 87% of the bacteria is left every day, forgot the is in there. How many grams are left after 12 days if there were 1,456 grams at the start of day 1. Okay. Geometric, because we're talking a percentage. So I'm looking for G sub 12. And that's going to equal my initial 1,456 is G sub 1 times R. What's my R value going to be? 87% is my R value. In decimal form, it would be 0.87 to the 12 minus 1 power. Straight up calculation. Oops, that's why. Anybody? It's rounded to the tenths. Yes? Okay. Quizzes tomorrow. Okay. Your quiz will have on it 12.3 stuff, and it will have on it some 12.1, 12.2 stuff, just to keep you thinking about what's going on with that one, prepping for next week, Thursday's test. Okay, so we got a worksheet today, and then that'll be due tomorrow.